This classical assumption in some ways is among the more important ones because when we violate it, it can cause some serious estimation problems for us. That'll become a little clearer later. Right now we just want to explain what the assumption is all about, okay? So what we're imagining here is that we have a model. Sorry about that. We have a model. And let's suppose this is a production function, okay? So we have alpha 0 plus alpha 1 labor plus alpha 2 capital plus epsilon, okay? And what we're imagining is that if we have a certain number of workers and a certain number of machines, we can get a certain number of units of output from that production process. And our goal in estimating this model would be to figure out what labor's contribution to output was. That's what this would tell us. And what capital's contribution to output would be. And that's what our alpha 2 would tell us. Okay? So the question is, what if we omit capital in this case and it ends up in the error term? Okay, now I want you to think about companies, businesses, if you would, perhaps manufacturing entities, okay? And we have some small manufacturing entities out there, and we have some large manufacturing companies out there. What would be true in the large companies? Well, they would have a lot of labor, okay, and they would have a lot of capital. That's what a big company would look like, right? A small company would have relatively little labor and relatively little capital. There's some substitutability between capital and labor, of course, but as we look from company to company to company, you know, what would be dominant in terms of determining output would be the scale of the company. How much labor and capital do they have? Well, once we omit capital and it goes into the error term, as we look from company to company, okay, a larger company is going to have more workers in it. It's definitely going to have more output. But part of the reason the output is larger is because the company has more of labor and capital. But the only part we get to see is the fact that it has more labor because that's all we have in our model. Okay? So what's going to happen as we go from company to company to company, let's say the companies are getting bigger, is that the computer detects higher amounts of labor and higher amounts of output, and it attributes all of that higher amount of output to what it can see, which is labor, when in fact some of it's due to the fact that it had more capital and therefore it had a higher epsilon, stochastic error. So the bigger companies not only have more labor, but they also have larger positive stochastic errors, which will drive output up. But we're going to attribute, the econometrics will attribute all of the increase in output to the increase in labor, and it should be apportioned partly to labor and partly to capital, but it can't because we've omitted it from our model. So the net effect of omitting capital in this case is going to be to over-attribute extra output to labor. And that's going to give us a coefficient that's bigger when we estimate it than it should be. Okay? So we have to work really hard to try to get all of those important variables out of the error term and back in the model. Okay? That's going to be our goal. But the assumption itself says all explanatory variables are uncorrelated with the error term. And a starting point for fixing that or making sure that that's true is to make sure that we have all of the relevant, important variables out of the error term and explicitly in the model. And we can take a few examples here to try to illustrate this. One of my favorites is the human fertility models. Okay, my early training was as a population economist or demographic economist. And so we would try to estimate, for example, the determinants of family size, especially in developing countries. So we would have the births of the ith household. And we would be trying to explain that with some variables. Education of the mother, for example. We might try to use income, and we would certainly at some point try to put in a measure of contraception use, okay? And we'd have a stochastic error, okay? So use would sometimes be the months of contraception usage that a couple reported on some survey, or there could be some kind of measure of intensity of use, but typically it would be months of use in the couple's married life, for example. And looking at this, we could make some predictions. We think probably that as education goes up, births go down, so we might expect a negative coefficient here. It turns out that in the data, as income goes up, births go down also, so we typically expect a negative coefficient here. And common sense would suggest that as contraception usage went up, births would go down as well, and so you might posit a negative value when we estimate alpha 3. And it's this that I want to focus on at the moment. In almost every econometric study with a regression that looks something like this, what would show up in the data actually would be that alpha 3 was less than 0. Okay? That is to say, when we estimate, sorry, I made a mistake, greater than 0. So when we estimate this model, we get exactly the opposite sign on the coefficient alpha 3 than we expect. If we interpreted that literally, we would say, well, clearly contraception usage creates larger families, and we know that that's not true. So what's happening here? Well, what's happening is that there is a variable in the error term that is confounding our results. There's a concept called fecundability, which is the probability that a couple conceives a child. And it's determined by the biology of the husband and the wife, or the two partners. It's determined in part by cultural practices, frequency of intercourse and things like that. But the fecundability, the probability that a couple conceives a child, is definitely contained in the error because we don't explicitly have it in our model. But that's correlated with contraception usage, right? So if a couple is recently married, and within 9 months they have their first child, and within 18 months or 20 months they have their second child, they have discovered that they are a highly fecundable couple. And so they are much more likely to use contraception, right, than a couple who's been married 4 years and has not conceived a child in the absence of contraception. So what happens here is that the couple discovers whether they are fecundable or not fecundable based on their experience. Then they choose to use contraception or don't use contraception based on that knowledge. Okay? And therefore, the more fecundable couples, the couples that are more likely to conceive, end up being more likely to use contraception. And because they're more fecundable, they've gotten pregnant more often, and they have more kids. So it looks like to us that contraception usage causes births, when in fact it's simply a case of an omitted variable that's causing some correlation between the error term and contraception usage. Okay, we could create a model of ice cream consumption. So let's say we had ice cream at some period in time, and we were going to put in some variables like the price of ice cream, the price of a substitute, and let's say income, average income in the community, and we have an error term. Okay? And so we might try to figure out, for example, what the effect of increases in income will be on ice cream consumption, and that would be revealed in the coefficient alpha 3, okay? But this is time series data, and let's suppose that the community that we're looking at has the property that a lot of its workers are seasonal. So employment is much higher in the warmer months, the summer months, and therefore income tends to go up in the summer months, okay? And we also know that tastes and preferences for ice cream are probably driven in part by temperature, okay? So temperature right now, average temperature in the month, is going to be in the error term, okay? Well, in a seasonal employment community, when the temperature goes up, this is also going up, okay? And what's going to happen is that the increase in ice cream that is in part due to temperature and in part due to income increases because of the seasonal employment is being fully attributed to the increase in income that we observe over the year in the summer months. And so we are going to overestimate that alpha 3. That is, our alpha 3 hat's going to be bigger than it should be because of this correlation between the error term and income. And that's what we want to avoid, so we're going to assume that doesn't happen.